Hello, everyone. Welcome to my home. This is my two friends, Herbert and Hubert. They are here to join you in learning some math today. Very exciting. I am Miss Chan. I have provided some assignments for my beautiful geometry students. Starting with this worksheet right here, says solving quadratic equations by factoring. This is super important in Algebra 2 or Advanced Algebra, so I'd love to go over it together. I'm actually really excited. We're going to start with number one, and if you remember anything about quadratics, you have two things you have to solve for. And basically, these two things, we don't know what numbers they are, but we have a way to solve for it. So here we go. Ready? We could say k plus 1 equals 0. Or we could say k minus 5 equals 0. Oh my god, so exciting. And then we could subtract 1 on both sides for this one right here. You should get k equals negative 1. And for this side, you could add 5 on both sides. And you could get k equals 5. These are your two solutions for this quadratic. It is very, very simple and it's very fun. See if you could do the same thing for this one down here. But this one has a 4 in front. Very, very frustrating. But you got this because you can do the same thing. You can set this first thing equal to 0, and you can set this last thing equal to 0. What you're going to do is you're going to still solve just like you were back in Algebra 1. So you could say 4k equals a negative 5 since these crossed out. Then you divide by 4 in this one, and this one's very unique because you get k equals negative 5 fourths. You can leave your answer like that, actually. I'm okay with that. I don't know about your other teachers, but basically, this is one of your solutions. Let's not forget about this other solution. That's one. I can number, I promise. And you should get a similar solution to the previous example, which was k equals negative 1 and k equals negative 5 fourths. Woohoo, so exciting! So before we start number 5, I want to take a look at the format that number 5 is in. Do you notice that it doesn't really have parentheses. Hopefully you see that. And that is because it is not factored. Hopefully you learned last year how to change this thing into a factored form. I will teach it in a moment. But before we even start that, this problem has a lot of weird things about it, like this 5 right here. What the heck? How do we get rid of that negative 5? Notice in number 3, there was a 0 there, and that's so much better. Everyone loves zeros. So what I'm going to do is I'm going to make sure there's a 0 on this side by probably adding 5 on both sides. This is not always going to be the situation in all these problems, but it's always good to recognize, talking and writing is hard, but it's always good to recognize a situation that's more familiar. And doesn't that 0 look a little more familiar? Also, you can change this into a more familiar situation by factoring it. Factoring meaning you can basically make two new things in two parentheses. These two things are called binomials because they have two objects. But the way to factor is kind of different. There's many different ways to do it. But the way I teach it is using this X method. Basically what you do is you take this number on the top, 24, and this number, negative 11 on the bottom. And you think, what two numbers multiply to 24 and add to negative 11? Oh, wait. It's 8 and 3. And it's negative 8 and negative 3 since that negative 11 is there. So then you can go ahead and place that negative 8 and negative 3 right there. And since your letters were x, we need to place those right there. So it's x minus 8 times x minus 3. Pardon my ugly handwriting. And now Doesn't this look a lot more familiar and looks a lot like number 1 and 3? So there's a reason for that, because now we can solve using zero product property. So you can say x minus 8 equals 0 and x minus 3 equals 0, because both of these could be 0, and then that means x equals 8 and x equals 3. Look at that. You just solved 2 problems. 3 problems. Oh my gosh. Okay, if you made it this far in the video, thank you for sticking for so long. But if you've taken a look at the next few problems, hopefully you see 5, 6, 7, and 8 are really similar. The 9 is where it gets interesting. So I want to help you guys out with number 9. Okay, and number 9 is different because if you look, there is a 6 in front of the squared letter. And that's what surprisingly makes it very different. So in this thing, we're going to figure out how to solve with a number in front. The way to get rid of this number is actually not the first step. What we're first going to do is similar to what we did in number 5. I'm going to get rid of that 6. I'm going to get rid of that 6 by subtracting 6 on both sides. So then we get 6n squared minus 18n minus 24, and it's now equal to 0. Remember that familiar thing that we saw earlier? This looks a lot more familiar. What I also see, and this comes with practice, is these 3 numbers are all even, and not only that, they're all multiples of 6. So I'm actually going to factor out a 6 from each of these 3 numbers. You can actually do that, and it's actually called the greatest common factor. It's factoring. So when you factor out the 6, you get an n squared minus a 3n minus a 4. That's what's left over in that parentheses. And let me write that 4 a little bit closer. But now we can actually factor even further. I know, so much factoring. This is still equal to 0. This 6 is still in the front. We're not forgetting about it. But now what we can do is we can factor it out so it looks a lot like number 5 and number 3 and number 1. So what we're going to do is we're going to do kind of similar to what I did before. I'm going to place the negative 4 on top and the negative 3 on the bottom. And you're going to think, what multiplies to negative 4 and adds to negative 3? Oh my god! What multiplies to negative 4 and adds to negative 3? Sharky, can you help me? Oh yeah, it's probably negative 4 and positive 1. Negative 4 and positive 1. That sounds about right. So then you can change this to n minus 4, where the n minus 4 comes from here, and the n plus 1, where the plus 1 comes from here. So now you have a much, much more factored out equation that can help you solve for n. In this next part, you can divide by 6 on both sides. What happens is 6 divided by 6 becomes a 1, which we can ignore because anything times 1 is itself. So this just becomes n minus 4 and n plus 1. But on the right-hand side, what's really cool is anything dividing into 0 is just 0. So what just happened was we don't really need that 6. That 6 goes away. And then the next part is probably what you can assume. We can set both things equal to 0, and you will get n equals 4 and n equals negative 1. Are you still here? Good, because I'm still going. So thank you for being strong. If you take a look, number 11 is really familiar, but let's take a look at number 12 and 13. If you notice, 12 and 13 have some things that are different on the right-hand side, but I'm going to probably do number 13. I'll just get you started on it. So on number 13, We basically want this side to be 0, so we have to do something with these two terms. I'm going to start with that 3 right there. All you have to do is think, what's the opposite of negative 3? So you can add 3 on both sides. What you can also do is you can get rid of this negative 5k squared by adding 5k squared on both sides. And if you notice, there is another k squared right there. So add 5k squared on both sides. When you combine all these two together, these cancel out and these cancel out. So this right-hand side gives you 0. But let's see what you get on the other side. You should probably get 1k squared. Hey, that's nice. Minus 8k. Negative 3 plus 3. Oh, that's 0. Huh, that's interesting. So ultimately, you get k squared minus 8k equals 0. This is super different from all of the other ones we've done. Notice we don't have a third term, just kind of like all the other previous ones. Notice all the other previous ones looked kind of like this, but there's no third term. There's just nothing there. So what we do in this case is actually dividing by the greatest common factor. And the greatest common factor in both of these two is k. I'm going to factor out a k. And what's left over is essentially k minus 8. That's still 0. What's really cool is you can now solve for k the same way as before. You can set this part equal to 0. And you can also set this part equal to 0. So you're almost done. You essentially found one solution, which is k equals 0. And with the second solution, you get k equals positive 8. And now you are done with number 13.
Are you ready for your last problem? Oh my god, what's this doing on my head? That was weird. Anyways, we're gonna do number 15. 15 is the last problem, and it's the last problem because we haven't really dealt with weird numbers in the front yet. And by weird, you will see what I mean in a second. So the first step is the same as before. What we're gonna do is we're going to subtract 5 on both sides to get that 0 on the right hand side. So we get 3r squared minus 16r minus 12 equals 0. So that looks a little more familiar. But this part is weird because if you look, are these all multiples of 3? Do these all have the same GCF? So it seems like it because of that 6 right there. But actually, these do not all have the same GCF. 16 is not divisible by 3. So unfortunately, you have to do another method. This other method is taught in very different ways. But what I do is I basically multiply the first and the last number by 3. And I remind myself using this bubble right here. So 3 times negative 12 is negative 36. Then what I do is the same x method as before. I put negative 36 on top, and I put negative 16 on the bottom. And then you gotta think, what multiplies to negative 36 and adds to negative 16? Herbert, you gotta help me. What multiplies to negative 36 and adds to negative 16? No, not negative 6 and negative 6. No, not 6 and 12. No, not 3 and 12. Oh, you're right. Negative 18 and positive 2. Thanks, Herbert. So your new factors are r minus 18 and r plus 2. Those are both equal to 0. Before you start solving, notice you multiplied by 3 before. So you have to reverse it by dividing by 3. And if you notice, one of these works out nicely, the negative 18 and 3, because this becomes r minus 6. But this second one, it doesn't work out as nicely. You get a weird fraction. So to kind of make things better, you can actually place a 3 in front. So you get 3r plus 2. And these are both equal to 0. And now you can solve for r just like all your other previous examples. The end! Thank you for watching.